All right, let's get started for this chapter 10. Actually, last time we talked about class, right? Yeah, last time we talked about class, right?
Yeah.
Are you okay with class right now?
Yeah.
Okay, today we are going through the slides for this class. Is that okay?
Okay.
Last time we give you a example on a real class, right? And have the class function, class variable, instance function, and instance variable, right?
Yeah.
So class variable is for what? Still remember that? What's a class variable for?
It's for
Class variable is for the general property for the class, right?
okay. Yeah.
So like number of account. You have a class called bank account. Then the number of account is associated with the bank. Then the bank own how many account? That's number of account for a bank is a class variable. And then instance variable is for what? For instance related data. Say I have a bank account, and that bank account has a balance. So every bank account's balance is different, but that data owned by a bank account itself is called an instance variable, and the number of account is owned by the bank. Okay, that's called class variable. So instance variable, you need to do what? Instance variable, you need to do self dot balance, right?
Yeah.
And then bank account, you need to do like bank account dot number of accounts, right? Okay, that's a different way of defining your class variable and an instance variable. So now let's look at what's class, what's module, and what is package. Okay, package is bigger. Package actually is bigger. So every time we actually see something like we actually already see something like mass from mass. Okay, import star, right? So this mass actually is a package. So a package actually is a group of files that actually have been designed by somebody else, so that you can use it as a library of functions. Is that okay? Is that okay?
Yeah.
Yeah. So basically, it will give you some functions to use. Say mass package, you have what? You have you have the square root function. You have the seeding function. You have flow function, different functions, right? And a module is a file, right? So you can actually do import some package dot something, some module, or import a module itself. So some program that we see last week, we actually some program that we wrote last week are called a module, but it's not a package. So a package is bigger than module. You can do some package dot module. A module is a individual file. So whatever AA.Python you wrote is considered to be a module. It's considered to be a module. So module is actually a Python file. It's called a module. Something.py is a module. And class is inside a module. So a file, you can put several class in there. And then a directory is called a package, and that package is bigger than a module. So let's see the program. So last time actually we go to here, say we have a circle class. You remember this circle class? This one? We have the number of circle.
Yeah.
Okay. And then this number of circle is actually a static variable, is a class variable. And so that control of the number of circles, right? Self.radius, this radius is a instance variable, it belongs to each circle, right? And number of circle belong to the class. Okay, and then import mask. This mask is a module. I'm sorry, is a package, and you can do import several file in from the mask module from mask package to your program. And this file circle.py itself is considered to be a module, and this module has a class called circle class. Okay, so here actually let me do another thing. Say here I have some file, okay, and I call it geometric objects. Okay, so I have a module called geometric object. So here I copy my circle in here. Okay, so my circle is in geometric class module, and I also ported the mask over here. Okay, import this one, and the circle class I make a copy. Okay, so here my circle class I change the name to rectangle. Okay, and I change the number of rectangle to number of rec. Okay, and then here you need what? Is a rectangle is no longer a radius, so it's like width and height. Okay, so number of rectangle should be is actually a number. So when you create a rectangle, it increase by 1. Oh, okay, this one actually, let me comment it out. We already have the that. Okay, so this one let me cross it out. Here is the number of rectangle increased by 1. Okay, and it doesn't has the, let me see, it doesn't has the radius, so we can have the width, okay, for the rectangle to be W, and then cell dot height equals H. Okay. Here, let me see. Number of circles. This one is number of circles. Let me delete this one as well. Okay. Okay. So this is the number of circles over there. This one's number of rectangle. Let me see. Increased by 1. Okay, and right here the area. The area is no longer pi r squared, so it actually should be its width times its height, right? And there is no longer the need for pi. Okay, and then reprint. We say it's a rectangle, right? And percentage f, and here we have self dot width and self dot height, right? That return the area, and then greater than, we will still be comparing two area, but it's no longer circle, so I change the name to R1 and R2. Okay, here I have R1's area greater than R2's area. Okay, and then this one I say R1, and then this one I say R2. Okay, but greater than for radius, for the rectangle is still okay. Okay, it's still okay. You can compare the area for rectangle 1 and rectangle 2. Is that okay so far? Hello? Is that okay so far?
Yeah.
Okay, so here actually I can do this. Okay, here I can do this. Define main function, right? I create a rectangle 1 equals rectangle I need to have width and height, so I say 3 and 4, right? And then I have rectangle 2 equals rectangle 5 and 2, okay? Okay, and here I say, actually, right here I say, print R1 dot greater R2, okay? So I create two rectangle and I try to compare which one is bigger, okay? And greater function is comparing what? Comparing the area for the rectangle 1 and area of the rectangle 2. Is that okay? So I define a main function and here I put main, okay? If I don't put main, will this program be wrong? Are you okay? If I don't put this main, will the whole program be wrong or no?
No.
No, why? Because this one is only a function.
Oh.
Nobody call it, right? And these two are just class and nobody use them, right?
Mm-hmm.
So this function use the two rectangles, right?
Yeah.
And this main function call the main function. If main doesn't get called, it won't be called. Okay, so here let me actually run it. So let me run this guy called geometric object. No attribute for number or rectangle. Oh, I'm sorry, this one is not circle anymore. It actually is a rectangle. Okay, I guess it's wrong. Okay, so one is 12, one is 10, and which one is greater? 3, 4, 12 is greater, right? You return the greater rectangle, right? Is that okay? Is that okay?
Yeah.
Okay, and right here actually I can add something called circle 1 equals circle of 5.0, and then I print circle 1 dot area, right? And let me try to do this. Can I compare a C1 dot greater than this one called R1? Is that okay or no? Can I compare the what? Can I compare a circle to a rectangle or no?
No.
Let's try. Okay, let's try. The answer is yes.
Oh.
Why? Because here I didn't say it's a circle or not circle, just the name is circle. As long as the function is the same. Oh. As long as the rectangle has a function, it actually is okay to call it. And this one is called, this kind of feature in Python is called, it's a special name. It has a special name. It's called duck function.
Oh, okay.
Okay, duck function. Why is called duck function? It says that there's a language, is a sentence say, if it look like a duck, and then it is a duck. If it quack like a duck, it is a duck. That's why it's called duck function. Okay, let me browse through the internet for you. Okay, this duck function only Python has it. Other languages don't have it. Okay. It's called Python duck typing. Okay, it's automatic interfacing. Whether it's allowed or not is called. I don't care. I don't care what is actually a circle or is a rectangle. But if the function actually a duck can quack, right? A goose can quack as well. So goose can quack, duck can quack. As long as goose quack like duck, then goose can be considered a duck. Is that okay? If a goose can quack like a duck, then goose quack function work as the duck function.
Mm-hmm.
Is that okay?
Yeah.
So here, let's see. Only Python has this feature. Other languages don't. Okay. So right here, actually, my greater I'm comparing to rectangle, right? Suppose the rectangle one compared to rectangle, but there's no saying that this is it should be a rectangle. So my rectangle one's area compared with my rectangle two's area. Even my rectangle two, I pass a. I'm sorry. Even if my rectangle, I pass a circle in there, then it still will treat the circle like a rectangle, and you will get a circle's area, and circle's area actually will go to here using the pi r square rule instead of using the rule defined rectangle. Is that okay? This is called duck typing or duck function. Okay, so right here, if you don't believe it, let me actually copy it, right? And this time, let me change the order. Let me change R1 to compare with C1. Okay, and then the result should be the same. So actually, circle has the bigger area, but this one is circle one calling area greater function to compare a circle to a rectangle. Okay, and this one is the object. This one is a rectangle one calling the greater function to compare a rectangle to a circle. And both will work because of the duck function feature. Okay, duck typing feature. Is that okay? This one is a special feature for Python. Only Python language has this. Other languages don't have this, okay? So now if this one is like geometric object, right? And here I put a main. Here I put a main, right? And this main function, it will run. So here, if I actually create a file, Python file called test geometric object, okay? So here I have a, and then here I say, let me import the geometric object. Geometric object. Let me see this one. Rectangle. No, this one is geometric object. Okay, right here, and then I just run this import geometric object. And actually, you know why? It actually run it once. Why? It run the main function one, the geometric object. Let me actually run this one called, let me save all. And then let me run this one called test. Run this one called test geometric object. And you will run the geometric object once. And geometric object function will run main. And then it will run all this. So here actually I should do this. I should do if name equals underline main. Okay. And then in this case, I say if my geometric object is a main module, then I will run main function. Otherwise, I don't run. Okay. So here, let me save, and let me go to the test geometry. At this moment, the main module is here. Is this one test geometric object? Okay. This test geometric object is a main module, and this geometric module is not a main module. So here, if I have this one and then I save and run, then as you can see, the main function no longer be run because I already say that. Okay, if my name is a main module, then I run my main function. Okay, if not, say here, if not, here I import a geometric object, but it is not, then I will not run my main function. So right here, actually I can do this. I can do, again, here I can do like R1 equals, R1 equals rectangle of 4, 4, right? And because I import a geometric object, so I need to write the name geometric object from rectangle. Then I can use this one, okay? And then I can do R2 equals geometric object dot rectangle of 5, 2, okay? And then I can compare R1 that greater than R2, okay? And then I print rectangle. Where is the rectangle? No attribute of rectangle. Let me see. I misspell it. Oh, this one is E. Okay, and then I run it. Okay, so 4, 4, 16, 5, 2 is 10. So R1 is bigger. You know, and here actually it doesn't run this one. Doesn't run this one because I say if I'm not main module, I'm not going to be running this main function. But here actually, here is actually okay, right? And if you finish this one and you say, I would like to run geometric object at main, right? What does that mean? That actually is running the main function from a geometric object.py function. So let me run this one. Right? So it actually running, after running this R4, it actually running this one, the main function defined in my geometric object. So I can use a different module to run the function defined in my geometric object. Okay? See that? Is that okay? So the function is something you can use the name of the module and dot to run, including this main function. Is that okay? Is that okay so far?
Yeah.
So basically, I have two modules. I have one module called this one called geometric object module. I have circle in here. I have my rectangle in here. I have a main function, right? And I say if the name equals main, I run my main, right? And then on the other side, I have another one called test the geometric object. Okay, and here I run geometric object main, and you will run this guy. I'm sorry, you run this back. Okay, you run this back. But if actually here because right here actually I say import. Before this actually I say what? Before this actually I say that import my geo object.
Okay.
So actually I can use this one, can use this one, can use this one. Whatever function or object defined in my module, because I imported already. But in order to use that, I need to put a name, the class name, and the module name before the class constructor, or the module name before the function. Otherwise, I cannot use it. Is that okay? So last time we talked about class, but this time I talked about module. Okay, I talk about module. And here I can actually also define my own main function. Right? And I can run my main function. Okay. So if I run this main function, okay, it's running my own main function. Okay, so actually right here, this main means this main, okay? But this main means the main in geometric module. So it actually belong to, not geometric domain, it should belong to here, right? Belong to this one. This is the main function over here, okay? And here I have this one called test module, test module. And that's the geometric domain. But here, actually, I have another way to use a module. I actually can also do this. From this module, I can import, import everything. Okay, in this case, my rectangle no longer need this. So two are share like a one file. So I can do this, right? I can do this. But in this case, because I remain this one, so this main actually will call what? You will not call the one in geometric object. You will call this one in here. You will actually exactly call this one in here. It's no longer the one from there. So if I run this one, what? Oh, I'm sorry. This one is before here. So this main only defined by in geometric object. But if I move it down here, okay, before this is defined, actually that function belongs to geometric object. So if I move it down, this one will only print the important thing in here. But if I cut here and put it here, the only main function defined will be in here. So this main belongs to here, the geometric object. Okay, so the definition of the function actually will define by the runtime when you run it. So if the main is not defined in my own module, it will use the definition from geometric object module. So the module is open to be shared. Then the namespace is shared. So this is name. The second time I define this, it will override the definition in the geometric object. So usually that is a passive, you know. And here, if you still want to do this function from that module, you can still put here and then put that. Okay, let's see how this works. This one is not allowed. So basically, when you open that, you can no longer use that one. You will lose it. You lose the main function. If it's been overwritten, you lost it already. So sometimes people will suggest not to use this way, just to import. Okay, some people will do that. So now let me change it back to the import. Okay, in this case, I no longer can call the rectangle because I don't have rectangle. The namespace is now open for me. So I need to do this one that. I need to do this one that. Okay, in order to run it. Okay. Are you okay so far?
Yeah.
So that's the relationship between package, module, and class. Okay, class is a data collection, and module is a collection of classes, and package is a collection of modules. Okay, so that's the relationship between that. And then the package you need to at least put something called init.py, and right here it's too difficult, so I just pass it. An object is an instance of a class. So you actually object is an active data type. So like a rectangle or your circle are basically objects. Okay. So more precisely, an object consists of a collection of related information, a set of operation like a reprint function or like a greater than function. Those are set of operation to manipulate the data. Okay. So the information stored inside object is called instant variable, and this instant variable, as I said, should be self-sensitive. Okay, the operation is called methods, and they are functions inside the object. So something like reprint is a function to operate on a rectangle or a circle. Okay, in each class definition, there is a method of the same name. That one we call it constructor. Okay, that one we call it constructor. Okay. And then init.py is optional. This one actually is used to set up the environment for your package. Okay, so here actually there is a underline all, and then there's a init.py. So this one too hard right now. Let's just pass. Here is the optional information. Too hard for you. And then defining the new class, you put a class name and modifier. So actually I showed it by circle already. So the circle right here is a class. You put a class name in front of it. You have a rectangle, you put a class name in front of it. Both are classes. Okay, both are classes. Okay, and then we have another project called MS-style object. Okay, so let's look at that MS-style object. Okay, MS-style object. So here actually I have another directory. Let me open it. Okay, it's not in here. Let me show you. It's actually I have to browse through it. No, let me see. It's not here. Actually, in this I/py is in this one. Zeta is in here. Let me see. In chapter 10. Okay, it has this one called roller package. Okay, so let me actually create here. Let me create a new project for this one. Okay, let me create a new project on that one. So here I have this one, I have someone jump there. I put on this chapter 10. Okay, I create chapter 10 as a project. Oh no, I'm sorry. I should create the project under chapter 10, the dice roller, let's say object. Okay, yes, open in different directory. Okay, so it should be right here. I open it. So this die roller has different project. Oh, it's not in here. Let me see. Let me see. This one's roller. Let me run it. Okay. Okay, this one is a die roller. Okay, Not this one. Let me try a different one. This one is called MSDIE. Let me try to find this one. Okay. It's probably in chapter 10, not in the one I just got. So I actually create the one in chapter 10. Chapter 10, this one. Create. So right here has MSI. Oh, this one. Okay. So this one is a die, right? It's a die. So a die is a when you play the die game. So a die has how many faces? You have 6 faces, right? Something like this, right? So you can roll it. So actually you can roll and then get number of the faces value, and then you can get the value and set to the value. Every time you roll, you'll get a value, right? And then you can also set a value. So that's a function for this die. That's a single die's definition. So this one actually create a class called MS die. Okay, but you need to have the range, random range. Random range, last time I talked about it, it will create a random number. So this one create a random number starting from 1 up to 7, but not including, if your number aside, you can put 6. So they are up to 7, but not include 7, so you will create random number 1, 2, 3, 4, 5, 6. Something like that.
Can I go to the bathroom?
Yeah, sure. Hello. Okay, so are you okay?
Yeah.
Okay, so now let's look at this one. We have this one define new class. Okay, we check this die project, right? So you need to know about how many faces you have and then set the current value. So this one underline in need, it will represent what? The constructor for the class name. Okay, so you can do MS die with the number of size. So the size was set to the size and the initial value set to 1. And then whenever you do that row, you will call a random range function. So here, say my main function, I define my dice to have 12 faces. And initially, I set my value to be 8, and I get value. So here, I should get what? I should get 8 because I set a value to be 8. Okay. And then let's go back to here. Go back to here. So here we have a class called this one called MSDie. So here I can actually do my definition of my main function, okay? And here I can create a D1 equals what? MS DIE of 12. Okay, this one is a 12 phase die. So then now I do D1 dot I say print my D1 dot get value. Okay. So what will be printed if I say D1 dot get value? What will be printed? After I use the constructor once, the value should be set to 1, right?
Yeah.
So it actually get a value, it should be 1. Wait. Oh, okay. I forget to type the main function. It doesn't get wrong. Okay, I'm sorry. Okay, so you get a 1, right?
Yeah.
Okay, then I can do this. So I can do D1.row. I row once, and then I print out D1.get value. So this one I totally run 15 times. Each time I roll it once, roll the die once, and then I get a value. So with this one, I do this. So what? I get a sequence of different random value. Is that okay? So if I set this phase to 6, it will be more like a normal die, 6 phase die. You should get 1 to 6 for 15 times. Is that okay? So that's the feature of this this one called MS die. It's just a die game generator. Okay. And then the next one, the cannonball. The next one is cannonball. I think it's too hard for you, it's including the physics, like the velocity I talked about with your dad this morning. So I think that one is too hard to think about cosine sine. Okay, you never learned this math, right? So let's bypass it. Is that okay?
Yeah.
You never learned the cosine sine. Probably 1 year, 2 years later, you will come back to here. Okay.
Okay.
The projector is fine. It's too much. Okay, this is too much. So the next one is the data processing with class, a student. A student program that can calculate GPA for student, including the name, hour, and total score, look like this. Okay, I have a student name, the total hour, and total score. So I try to calculate the GPA. So each student, I use a constructor, putting in the name, hour, and Q point. Q point is the 4, 3, 2, 1. A for 4, B for 3, C for 2, D for 1. Like those kind of numbers. So you know about how many hours it takes and then how many points you got. And you can get name, get hour, get Q point. And the GPA is the Q point divided by hours. Okay, total Q point you get, and then divided by total hour you get. So that actually you can do max student, and the max student actually you use what? You use the keyboard key in, and then actually use the split. Split will split the information and then assign to these 3 things, and then you actually use the student constructor to generate a student. So max student will make a student and return that student to the upper level. So here is the main function. You actually open the file name, and then actually you make a student and run. Okay. So this one, let's look at here. We have the GPA program, right? So this one is a student class, a GPA program, and there's a max student, there's a main function, and the student information is right here. So the student information right here. Let me delete this one, okay? That is unbelievable. I don't know what symbol it is. So here, let me actually save all. Okay. So here you see, here has a different student, and the first number is what? Total number of hours. Second one is the total Q points, right? So all the Q point and hours, okay, for some high school. So the GPA program actually each time for the main function, it will let you open the file, okay? Open the file name. So my file name is student.txt. So I open that file and then I read a line and read that line in, and then I calculate the GPA and then compare to the best student. Okay, so if my point is higher than the best student, then actually I will replace the best student until, so I keep looping each line, I get a student until I find the best student, right? And then I print out the best student's name, hour, and total Q point and GPA. So this one, let's run this GPA program. And it need me to enter a file name. This one is called student.txt. And student.txt is over here. I have the name and the number of hour and the Q points. Okay, so here let me run it. Okay, so he found the best students to be this guy called Frasto Brandt. So Frasto Brandt, where is the Frasto Brandt? Oh, it's just like, it's just right here. The GPA is around 3.78. Okay, his GPA is around 3.78. Total point 397. Okay, but his hour is 105 hours, so it's like 3.78. Okay, so that's the main function for this one. In the student file over here, the result, we got this one. So the next thing is encapsulation. Encapsulation means that I try to make sure my data can only be accessed by my method. So for example, for my die function, for my MS die function, you can only get my value by using get value. You cannot, actually it's okay that I actually print this. It's okay that I actually do this. It's okay that I actually do print D1 value. Okay, it actually is legal. Okay, actually it's illegal to do this. Okay, but it's not suggested to do this because you may change the value incidentally. So actually it's okay to get that value, but a better way to do this is just get value using the function to access it. So they will reduce unnecessary setup for the values. Now you actually set the value just in the wrong way. Okay, so this is called encapsulation. It's to hide your information from the user, so you can only access the data by using the functions. Okay, so a module can have several classes, and then you need to you need to do something. And then the next one is called docstring. Docstring is a string defined in a class. So under your class, you can put something triple quote. Those are called what? It's called a docstring. And docstring can be used whenever you actually do help. If you do help in your console system, it will show up. So right here, let's do this. Let me go back to my. Let me go back to my rectangle one. Let me see. Okay, chapter 10 demo. Not this way. Let me go back to chapter 10 demo. Right here. Okay. So right here, actually, I can do triple quote. Okay, and I say docstring here is like rectangle class. Okay, and then I can say like it has what? It has a class variable called number of rectangle, right? And it has a data field. Let's call it instant variable. And then it has the width. And there's another one called height. Right? And you can say like definition of a rectangle. Okay, so after that, actually I can save, right? Save my file over here, and I can bring up my console. So this one in triple quote is called docstring. So it actually is declaring the docstring with a triple quotes. Okay, so actually it should be what? I should type using help on module. Let me see. What's that? Oh, I see. It should duck, underline duck. Okay. So it's called underline duck. I can do this one and underline duck. I should put my geometry. I forget to insert import. Geometric it's not a from that file import, so actually I should do this. Okay, by doing this, actually you will get the docstring I define in the object. Okay, it's a little bit complicated, so actually for me I seldom use it, but it's a way that people use it for providing the documentation for people that they can search for it. Okay, is that okay? And the next one is the namespace. Namespace is like if you do from something import something that will merge into your current namespace. Okay, but if you do import something, you will not merge the namespace, and then you will actually use the projector.something to access some function or class. Okay, but this one again, Cannonball 4, we will bypass it because it actually has a physics topic. The next one is a visual interface object. It's called widget. Okay, which is called window gadget. Okay, so it's a widget. Widget is a interface like this. It's called a widget. Okay, so that's the last function for today. We have this widget about 6-7 pages. So there's a file called widget, and we design something like this. Okay, so there's a class called button. So this class button is used to design the roll button, quick button. These two are buttons. Okay, so button is a constructor that you can create a button in a window, and then you can activate for the button, deactivate for the button. Once activate, activate is this one that we in solid color. Deactivate is gray, it's not in solid color. So that is not useful. And you can only click on the activated button. Okay, then there's a click, get label, and different functions. So let's go to the button class. Okay, button class, let me actually, it's not in here, it's not in Cannonball. It's in this one with the roller. Okay, so I get the button. So this is a button class. Again, it has a docstring over here for description. Okay, so this one actually needs a D over there. So there is a constructor called init function, right? So get the width, height, and label, and calculate for the different width and label, and then put in the color as light gray, and setting the button to be disabled because it's not used. Then if you click, you return the value for the mouse click location, and activate the button as well. Okay, and then get label, activate, there are several different functions for it. Okay, that's the function for button. So it's design of a single button. Okay, and here it defines the buttons region. Okay, and then after that we have another call here, different function for the activate. The next one is a die view. Okay, die view is create die's location. So right here we have a 7-point system. What are these 7-point system? Because we are going to design a die that can be 1. 1 would take the number 4. Okay, 1 would take number 4. And then if I have a 2, it will take here and here, so it will be 5 and 3. If I take 3, it should be here, here, here. So it actually is 5, 4, and 3. If I take 4, it will take 4 corners, 1, 3, 5, and 7. If I take 5, you will get this one. So it's 1, 4, 5, 3, 7. If I take 6, it should be this one, this one, this one, this one, this one, this one. It will be 1, 2, 3, 5, 6, 7. So I only have 7 possible dot location. And with different die value, I can actually draw different dot so that I actually can print out the right format for the die. Is that okay? It's somewhat complicated, okay, somewhat complicated in this function. And this one probably the most complicated function of all in this book, okay? So this die view will make peep and then have different dies, different things. So only number 4, you will set to red. Only number 1, the background color should be set to red. Other than that, everything in black color. Okay, and then the roller.pyw actually will create a row dice and set coordinate, set the color, and then let the program to go into the event loop. And then it will actually keep waiting for quit button. If button is quit, then quit the program. Otherwise, it will keep running. So let's see how it works for this row dice. This one is actually in roller project. So the main function is here. We have this die view. Die view has set up for different things, for lots of different dots. So here I have a roller, and this roller actually, right here, I have a die, right? And each time I hit it, it will actually print out different die. Okay, and if I click quit, you'll finish the program. Okay, so far okay. And the program is a little bit complicated, but this chapter 10 is about that. So you work on the exercise 1, 5, and 9. Okay, is that okay? Hello, are you all right?
1, 5, and 9.
Yeah, 1, 5, and 9. This program, the whole roller project, I will send it to you. Okay, the whole roller project, I'll send it to you. So probably I think this one you probably need to study with your dad. Okay, it's a long reading program, and it's hard. Actually, I try to go through it, but so many different function and statement to be read. Okay, is that okay? So I'll send this project, this file, chapter 10 file, and the whole program to you.
Okay.
Yeah, if I extend the whole program, I think it takes 2 hours, 3 hours to finish. Okay? But try to read it. If you cannot understand, let me know. Other than that, the program in this chapter is not that hard.
Okay.
Okay? So that's it for today. Thank you.
Okay, bye-bye.
Bye.